Alright, in this video I want to show you how you can simply derive the formula n all over n naught equals to e to the power of negative lambda t, where n is representing the number of undecayed nuclei and this is undecayed nucleus, while n naught is the number of the initial amount of the nucleus, initial amounts. All right, lambda is the decay constant, and then t is the time duration of concern. So let's get started. Recall that the activity, which is the rate of decay per time, depends or varies as the amount of undecayed nucleus. So A varies as n. So we can write this as, we can change this proportionality statement to equation by introducing a constant. So A is equal to lambda multiplied by n, where lambda is what we call the decay constant. However, at any point in time, we have always having a decreasing number of nuclei, and so the lambda here is going to take a negative sign. So we can write this appropriately as A equal to negative lambda n. And we also know that A, which is activity, which is decay per second measured in becquerel, BQ, becquerel, is usually equal to the rate of change of n respect to time t. So putting this into this place, we have that the n over dt is equal to negative lambda n. So we can write this as the n, letting the t to come to this other side. The n is equal to negative lambda n multiplied by dt, and to eliminate this n, we can divide through, or multiply through by the inverse of n. So we have this to be the n multiplied by the inverse of n must be equal to negative lambda n multiplied by dt into inverse of n, so that this n cancels this n. We are left with the n into 1 over n is equal to negative lambda dt. Next we do is we integrate both sides. If we do that, we shall have this to be integral, take the integral of 1 over n dn is equal to negative lambda integral dt. Going forward, the integral of 1 over n respect to dn is simply ln n. So the n will be equal to negative lambda. Integral of the t is simply t plus some constant. To find out what the constant is, let's take the limits. So as t tends to 0 seconds, n will also tend to initial count, which is n naught, so that lane n naught becomes equal to negative lambda t is 0, negative lambda into 0 plus c, so that lane n naught becomes equal to this cancels to become 0, equal to c. So c is equal to lane n naught. We can now come back and plug in this guy into c here. Doing that, we have that lane n is equal to negative lambda t plus lane n naught. At this point, our concern is to have this and this to be on one side, so we can subtract lane naught from both sides, so we have it to be lane n minus lane n naught equal to negative lambda t. Lane into n divided by n naught equal to negative lambda t. For us to get rid of this lane, what we can do is introduce e of both sides. If we do that, we have that n all over n naught will be equal to, okay, let's make it clearer. Let's make it, what we can do is, so e, we have e raised to the power lane n over n naught. This must be equal to e lambda t. Of course, this will cancel this. We are left with n all over n naught. E is equal to e raised to the power negative lambda t. We can also express this as n equal to n naught into e raised to the power negative lambda t. In the next episode, I'll be showing us how we can derive the formula of the half-life of a radioactive element using this decay equation as our base. Alright, if you are watching from our channel, make sure you subscribe before leaving so you'll be able to know whenever we upload videos.